Hi everyone, today we are going to be working on integer division. So what we call this is long division. So our example problem is 27,692 divided by 23. First, let's start by going back to the meaning of definition, or the meaning of division, the definition. That is when we distribute some amount of stuff equally among a certain number of groups and then count how many is in one group. So you can see here, I've written out the 27,692 in block form. So we have 2 super rods, 7 super cubes, 6 flats, 9 rods, 2 singles. And what we're going to do is we're going to divide all of these up into 23 groups, which I've drawn at the bottom. Because I didn't want to write out 23 groups, I just did one group, ... 23, just to symbolize that there's going to be an equal number of these cubes in each of the groups. So first let's just start by looking at our numerical problem. So the first question we're going to ask ourselves is, how many times can 23 go into 2? And the reason we do this is we can look at just this first number, the biggest place value that we have in the number that we're dividing, because we're going to start by just looking at each unit separately as we move through these place values. So first we're starting with the 2 super rods. And because we want to divide things, have an equal number of stuff in each of our groups, we don't have enough of these super rods to give each group an equal amount of stuff. So now what I'm going to do is I'm going to break down each of these super rods into 10 super cubes each. So I'm just going to do that by drawing 2 super cubes and ... and that represents 10 of our super cubes. So again, what I did is I took this super rod and I divided it down because we need to distribute some amount of stuff equally among the 23 groups. So I'm breaking it down into the next unit next to it, and that's going to give us a total of 27 super cubes. And that's the same as going here and saying, okay, we couldn't divide these 2 equally among the 23, so we can just draw a 0 here, but we don't really need to write it. So next we're going to do, how many times does 23 go into 27? Well, it goes in there 1 time. And that's the same as us saying, we took all of these 27 super cubes and we gave 1 to each of the 23 groups. And then, because next what we're going to do is 1 times 23, and that's the same as saying we gave 1 to each group, and that was a total of 23 super cubes that we gave away. And now we want to see how many super cubes we have left over. So we're going to do 27 minus 23, and we get 4. So that means all of these have been accounted for, all of these have been accounted for. We have these 4 left over, and that's the same as this 4 right here. So next what we need to do is we're going to break down these super cubes. Because we can't divide them equally, we need to break them down into a smaller unit, so our flats, and that's going to be the same as bringing down this 6. Because once we break down these 4 super cubes, that's going to give us 46 total of the flats. And the reason we can just look at one place value at a time is because we're only acknowledging these units. It's like if we were to divide up like cookies and apples, right? We can't consider all the apples and the cookies together because they're separate units, they're separate things that we want to divide equally. So now we're going to divide these flats. And because we have 46, we know that 23 goes into 46 2 times, which is the same as us saying that these each group is going to get 2 flats. So we'll draw in the 2 flats. And then we do 2 times 23, and we get 46. and that means we have 0 left over. So all of these flats were accounted for. And the reason we just did 2 times 23 and not 12 times 23 is because, again, we're only considering that unit. And we only considered the flats in this situation, and we gave 2 to each. We didn't give 12 to each group. So next what we want to do is we're going to, again, bring down this 9. And that's going to be the same as us considering all 9 of these rods. But again, we don't have enough to give 1 to each of these groups. So what I'm going to do is I'm going to say we can give 0 rods to each group because we don't have enough to fill all 23 groups. So then what we're going to do is we're going to break down these 9 rods into singles. So it'll be 9 groups of 10 singles. So now we have a total, or first what we need to do is we need to say we gave 0 rods, so 23 times 0 is going to give us 0. So then we still have 9 rods left over. And when we broke down these 9 rods into 9 groups of 10 singles, that's the same as creating, or considering all 92 of the singles, because we started with 2 singles, then we broke down these rods, and that's going to give us a total of 92 singles now. So now what we ask is how many times can 23 go into 92, which is the same as us saying how many of these singles can we give to each of the groups. And if you need to do a side problem, that's okay. So let's just try maybe 23 times 4. 12 carry the 1. That gives us 92. So perfect. Each group is going to get 4 of these singles. Let me symbolize that. I did 4 singles in each group. And then if we are going to write the 4 up here because we gave 4 singles to each group. So then 4 times 23 is going to give us 92, the problem that we already did. If we subtract, we have 0 singles left over, which means all of these singles were distributed equally and accounted for. So now we see that our answer is 1,204. And we see that here because we have 1 supercube, 2 flats, 0 rods, and 4 singles. You get an answer of 1,204.